Atmospheric pressure, Part 1. Objective: to understand the concept of atmospheric pressure. Take a tin can which is filled with water to about 1/3 of its height. Now, heat the can so the water starts boiling. As the steam starts coming out of the can, the little amount of air filled inside the can also escapes from it. Now the can is completely filled with steam. Next, close the lid of the can tightly and pour cold water over it. What did you observe? The can gets crushed badly. This happened due to a physical phenomenon called atmospheric pressure. We know that our planet Earth is surrounded by a blanket of air called the atmosphere. Like all other fluids, the air also exerts pressure on everything within it. This pressure is caused by the weight of constituent molecules present in air, which reacts from Earth's surface to the atmosphere above. Due to their weight, the molecules in the upper layer compress the molecules in the lower layer. Thus, the layers of air close to Earth are more compressed than those above. All the bodies on Earth's surface experience pressure due to the weight of air column above it. This kind of pressure is termed as the atmospheric pressure, and it is defined as the force exerted per unit area of a surface by the weight of column of air molecules above that surface. The average atmospheric pressure at sea level is 1.013 into 10 raised to 5 Pascal. This value is referred to as 1 atmospheric pressure. This pressure is almost equivalent to placing 1 kilogram mass on an area of 1 square centimeter. But in spite of such an enormous pressure, our body doesn't get crushed. This is because our body is made up of cells, and these cells are filled with liquid. The pressure exerted by this liquid on the wall of the cell counteracts the atmospheric pressure. Moreover, the blood flowing inside our body also exerts a pressure called blood pressure. On the whole, our body is able to exert an outward pressure, which equalizes the atmospheric pressure pushing down on us. This is why we normally do not feel the pressure exerted by the atmosphere. Now, let us try to understand our previous experiment. Under normal conditions, the atmosphere exerts a pressure on the walls of the can. Simultaneously, air molecules inside the can also exert a pressure on the walls of the can. Both the pressures balance each other, hence the can remains stiff. But when the can is filled with steam, there are no air molecules left. When cold water is poured over this can, the steam condenses to form water, and there are no air molecules to exert any pressure on the can's walls. The atmospheric pressure still acts on the walls, and due to this atmospheric pressure, walls of the can collapse.